Lesson 9.3 is hyperbolas. The definition of a hyperbola is also a locus of points. So again, set of all points is the same thing as saying a locus of points in a plane, the difference of whose distances from two distinct fixed points, these 2 points are called the foci, is a positive constant. In a hyperbola, we have 2 foci. The foci are going to be in the inside of each of the 2 branches. As with the other conics, we have 2 different forms for a hyperbola. We have a horizontal and a vertical. So first, the horizontal transverse axis, the formula is x minus h quantity squared over a squared minus y minus k quantity squared over b squared is equal to 1. The transverse axis is the axis that's going to connect the vertices. So let's draw a diagram to go with a horizontal transverse axis. In a hyperbola, we will have 2 branches. Here we have 1 branch. The other branch will be symmetric to that branch. Draw on them the best you can. Each branch has its own vertex. So here is a vertex. We'll call this V1 and V2. Halfway between the vertices, we have the center. Here is the center. We'll call the center C. And then the foci are inside each of the branches. So here we'll call this focus 1. And on the left branch, we will put that point there, and that will be focus 2. So the distances that we learned in the ellipse section are the same here. So the distance from, let's do the distance from we'll start with the center to each vertice. That distance here, center to vertex, just like we called it in an ellipse, is A. The distance from the center to a focus point, just like in the ellipse, that length right there, that is represented by C. And we also have co-vertices in this case. And so my co-vertices are going to be above and below the center. I will call them CV, so CV1, and co-vertex 2. The distance from the center to a co-vertex, just like in an ellipse, is the distance of B. So this length right here is going to be B. Now what we can do is we can actually form a right triangle. We can see that the segment from the center to the co-vertex and the center to the vertex are perpendicular. This forms a right angle. And that value of C, if I were to connect that length C, that's the same distance as from the co-vertex to a vertice. So that is also the same length as C. Sorry, that segment's kind of crooked. This distance here from center to vertex 2 is also A. So inside there we can see that we have a right triangle. And using the Pythagorean theorem, we can see that for an ellipse, for a hyperbola, we have A squared plus B squared is equal to C squared, so that we can find the values of A, B, and C in their relationship to each other. When we are graphing this, we are going to make our box in the inside. And the box we're going to make by connecting a vertical segment through each vertex, a horizontal segment through each co-vertex here to get this box. This box will then help us find our asymptotes. Each hyperbola has 2 asymptotes, and those asymptotes go through the corners of the box. If I go through this corner, the top left and the bottom right, this will be an asymptote. Each of the asymptotes also passes through the center. Now, if we look at the asymptotes, we want to find the slope of the asymptotes. So the slope of this asymptote here, the slope is going to equal, well, I know it passes through the center. From the center to get to the corner of the box, I'm going to rise the distance of B and run the distance of A. So my slope is going to be B over A. The other asymptote, this asymptote here, my slope, here I'm going to rise the distance of B and run the distance of A, and that's going to the left, so it's just going to be negative B over A. Oops. And that's how I find the slopes of the asymptotes. Now I also know that each asymptote passes through the center, so I can use the slope of B over A and negative B over A, and also the point of the center to write the equation of a line using point slope form. The exact same thing goes for the vertical transverse axis. So for the vertical transverse axis, my equation here is going to just switch around. My y's are now written first, so it's y minus k quantity squared over a squared minus x minus h quantity squared over b squared is equal to 1. Notice the only thing that changed is the numerator. So the numerators switch. So here I have y minus k as my first numerator, the positive term, and here I have y minus k as the negative term for the horizontal transverse axis. The denominators, notice the denominator stayed in the same spot. A squared is my first denominator of the positive term. A squared is also the denominator of the first term, which is the positive term. In this case, there is no relationship between the size of A and B. As in the ellipse, the A was always greater than the B. In this case, A could be greater than B or A could be less than B. It doesn't actually matter. So to find the diagram for the vertical transverse axis, our hyperbola simply has branches that are opening up and opening down. Everything is going to remain the same, so halfway between we have the center. Each of the branches has a vertex and a vertex. We have the foci, F1, F2. We can make our box, my covertices. So covertex, maybe this one's going to be longer. Covertex 1, covertex 2. I can make my box by making my horizontal, now my vertical, my horizontal, the vertical. And then you can find your asymptotes by going through the corners of the box and the center. And these asymptotes will help you make a better branch when you're actually graphing it. And that is a hyperbola. Now take a minute to complete the bottom half of the first page of notes under things to remember. Pause the video now and complete that section. Let's check and see how you did. Please check your answers. I forgot to talk about the second axis, is the conjugate axis, this one right here. So the conjugate axis is perpendicular to the transverse axis, remembering that transverse connects the vertices, and since it connects the co-vertices and the center to a vertex is B, the length of that is going to be 2B. Under the slope, please make sure that you have both of the options written down. So the slope will be plus or minus B over A if it's going to be a horizontal transverse axis. And then we have this equation here, y minus k equals plus or minus b over a times the quantity of x minus h. The other case, if we have a vertical transverse axis, now the rise is a and the run is b. So we have plus or minus a over b, and now our point slope form is y minus k equals plus or minus a over b times the quantity of x minus h.